we're solving problem 23 from Amc 10A from 2020. Let T be the triangle in the coordinate plane with vertices 0, 0, 4, 0, and 0, 3. Consider the 5 isometries, rigid transformations of the plane, rotations of 90 degrees, 180 degrees, and 270 degrees, counterclockwise around the origin, reflecting across the x-axis and reflection across the y-axis. How many of the 125 sequences of these 3 transformations, not necessarily distinct, will return T to its original position? So, I have drawn the triangle out here, and let's just talk about the degrees rotation. For the degrees rotation, if it's have to rotate a full circle, it's going to be either 360 degrees or 720 degrees. And why does 720 degrees work? Well, if it's a sequence of 3 transformations and the max is 270, 270 times 3, since you do that 3 times, this is going to be 810. 810 degrees moved. And 720 is clearly less than 810 degrees, so that is why we can do that. Let's consider 360 degrees. What can we break it into threes? Well, the only thing we can break it up into is 90 plus 180. And these work. Now, there's only 3 ways to do this. And this is the end of case of 360 because this is the only way to have a sum of 3 degrees that's either 90, 80, or 270. Now let's consider 720 degrees. 720 degrees is going to be 270 degrees plus 270 degrees. That's 540 degrees plus 180 degrees. And this is also only 3 ways. And this is the only way to break up a 720. So, we can sum these two up. 3 plus 3 is 6. And we are done with finding how much degrees, like the amount of ways you can do it with degrees. Now, let's consider it with reflections. And now, there's either a reflection y or a reflection x. And let's just see here. Since they're all different, there's this one case, reflection x. If you do a reflection across the x-axis, then a reflection y, it will get you here. Then you'd have to move 180 degrees. This is the only one involving reflections. And since these are all distinct, we can do 3 factorial. This is 6. So our answer is going to be 6 plus 6 or 12. And we're done.